Hi, during one of our recent webinars dealing with Postgres basics, we presented on 10 key differences between PostgreSQL and SQL Server. At the end of that webinar, there were a lot of really good questions. And so we wanted to take an opportunity to really give back a little bit more out of that webinar. We know it was really packed full. I warned you that up front. And so we wanted to make sure that we answered as many of these questions as we could. So hopefully this would be a good opportunity to just level up a little bit more about the differences. So the first question that came up was, how much memory does each connection in Postgres take? Well, I hinted at this in the webinar, and it really starts to, and I am making an assumption that we're talking about the amount of memory of a connection for running a query. So in SQL Server, we are used to the query planner planning a query, figuring out what it thinks the amount of memory, called a memory grant, is to run that query. And then it will request to reserve that much memory so that it can do its work. That's not how Postgres works. The real key setting here, one of them, but really the key one in most of the things that you're going to do, is the setting called workmem. Now, workmem is the maximum amount of memory that each node in a query plan can use for specific kinds of operations. So if you have a very complex query with lots of group bys and order bys, each one of those operations can use up to workmem. If you have 2, 3, 4 of those operations within your query plan, it's 2, 3, 4x of workmem. So the operations that can use this memory are things like order bys to stinks, and then hash operations like joins, hash-based aggregates, and then even things like hash-based processing of subqueries that use an in clause. So this is straight from the documentation. You can look and see what some more of these operations might be. It's just the recognition that the more complex your query is and the more data you have, if that setting is not big enough, when Postgres needs to do things like sort, it will have to spill that data to disk to use disk space. If you have enough memory, it can do that sorting in memory. So really understanding how much workmem you need, there's a lot of good documentation online, a lot of good blog posts around how to tune that, and there's more work being done with every release to give you feedback so that you can really tune that well. So that is the key setting for you to go investigate when you're looking at the amount of memory your connections are taking in relation to Postgres. Now, this next question we had was, what is the difference between vacuum and analyze? So I mentioned vacuum and analyze a number of times during the webinar. And again, some of these are really foreign concepts to us because in SQL Server, some of this doesn't really exist in the same form, or it's called something different. So the real main job of vacuum is twofold. The first is vacuum manages the transaction IDs in the transaction IDs namespace, as it were, within Postgres. So as transactions occur and old data becomes old and is no longer needed, those transaction IDs can be reused later in the future. There's this whole concept of a circular transaction space within Postgres. And so Postgres needs to maintain that and needs to advance the oldest transaction ID that is currently in use, things of that nature. The other thing that it does is actually free up disk space. We talked briefly about MVCC, multi-version concurrency control. And the way that Postgres does it is as you insert or update a new row, any row, a new row is always created in the pages of the table. In SQL Server, those changes, the data that's needed for currently running transactions, but has been modified by a different transaction, that data is stored in tempdb. In Postgres, it's actually written into the pages that store the table data. And so as that older data that's no longer needed by any transaction, it can be cleaned up, it frees up disk space within that table. If you don't manage it well, I mentioned a few times the idea of table bloat. And that means the pages where the data is stored will actually kind of become fragmented, and you'll get more and more pages if vacuum is not doing its job. And so those are the two main reasons, things that vacuum does. There's a lot of other nuances in there, The key concept is that vacuum is really necessary. And then analyze is simply about updating statistics. So we have, the SP update statistics procedure to make sure that happens. We have the trace flag that I referenced, I believe, in the webinar itself. Ways to keep statistics up to date within Postgres, and that is the job of analyze. So I mentioned these couple of things. Auto vacuum and auto analyze, these are configurations. They really should never be turned off. Unless you really know what you're doing and there's a really specific reason, you really should make sure they stay on, and that means the vacuuming will continue to take place as necessary. And we referenced in the webinar that these things trigger very similar to how statistics are updated in SQL Server. Both auto vacuum and auto analyze will run anytime a table has modification of 20% of data for auto vacuum or 10%. You can modify those values based on your workload, and I absolutely recommend that you should. So give those a look. That is the job of vacuum and analyze, and these are things you really, truly need to understand as you move to Postgres because they're very essential to running a healthy database. Now let's talk about this question. If every update creates a new row, does that hold true even when an update doesn't change any data? The simple answer is yes. And so this, again, is a little bit of a foreign concept to us in SQL Server when we're dealing with data. In some ways, again, mostly because the data is not stored in disk, right? In table, it's managed externally and whether or not the data is actually modified. So here's a really simple test you could run on your own, and I just wanted to show it to you. I actually did this right in Postgres as a quick example for you. I created a table, I inserted a value, I selected, we talked about xmin and xmax. I selected those values, and you'll see that xmin, this is the transaction ID, 11,801 was what that row got. And then I simply said update that value to itself, and I wanted to see if the transaction ID would change. And sure enough, it did, right? 11,802. So Postgres is not doing anything magical to see if any values have changed. It's a transaction. The transaction said, update this value to this other value. Whatever that value is, it will insert a new row, and that old row with an older transaction ID will then be cleaned up by vacuum when it is no longer necessary by other transactions in the system. So that is what happens when you update any row in any Postgres table currently. As of Postgres 15 and soon to be 16, there are some updates coming in the future and some forks that people are working on of ways to avoid some of this with the transaction space. So keep your eye open to it, but it is something to know and understand as you're dealing with Postgres. Is there something similar to CTEs in PostgreSQL? This came up and I was able to answer really briefly at the end of the webinar, but I just wanted to reiterate that there is lots of support for anything really SQL. And I say it this way, absolutely. There are CTEs, there are cursive CTEs. In Postgres, you have lateral joins, which is very similar to an apply statement. And there's lots of other really tangible, really sophisticated SQL things that you can do. And really that's what you have to understand is that Postgres has really, the developers have really made an effort to hold as close to the SQL standard as possible. And so if it is a SQL standard in some way, there's a really good chance that Postgres supports it. If it doesn't, there's probably a reason that it doesn't, and it might even be worked on. Merge is a good example. Merge is actually part of the SQL standard. It was not in Postgres until Postgres 15. It had been attempted a number of times, but the community is very, really wants high quality features to be added, and they will iterate sometimes for a couple of releases before they will add a feature, even if it's part of the SQL standard. So that's a blanket answer. I don't mean to imply that Postgres supports everything, but if you are used to SQL things, there's a really good chance that Postgres supports it. As I mentioned in the webinar, we have to be careful that what we call SQL as SQL Server developers is actually Transact SQL, T-SQL. And so there are a lot of functions and statements that we believe or we kind of get used to being just plain old SQL, when in reality they are SQL Server specific functions or ways of doing things. So, but CTE, recursive CTE, are part of the standard, and it's absolutely something you can do within Postgres. Does Postgres have built-in full-text search? And I'm happy to report that it does. It's actually been around for a very long time in Postgres. There's a lot of really interesting things that Postgres provides, some of which came out of this ability with full-text search. So when you do search on a text field, so any text field, you can actually do the equivalent of a full-text search, even without an index. We have this idea of what we call TS vector, so text search vectors, and queries, TS queries. And so you can, I'll show you an example in just one second. You can essentially say for this text field, create a vector out of it, and then probe or query that vector with this TS query statement. Now, the benefit is out of that work, we have things called GIN and GIST indexes, but specifically GIN indexes can be added to or put over top of columns of data, or you can actually create as calculated columns of your text as TS vectors, which can then also be indexed. There are multiple ways to go about this. There's actually really good documentation in the Postgres docs and lots of really good articles online. So there's some really powerful full text search capabilities within Postgres built in out of the gate. You can use it anywhere that you use a text field. It also comes with things like the abilities to rank your results, and a lot of other opportunities, partially because of those indexes and other query operators that come as part of full text search. Here are just a couple really quick examples. I stole these right out of the Postgres documentation. There are more than this, but you can see that simply creating a vector of a column body, I can then query it with an English word friend and see, is this anywhere in that body of text? You can create these indexes over top of your text columns, which make it faster then to do these vector and query searches. Or, as I said, you can take a column, create a generated column as a vector, and then index that, which gets you even a faster searching as an indexable search. There's a lot of good documentation here. You can go to this URL, and there's they've done a very good job within the Postgres docs to really go over all the things you can do with full text searching in Postgres. So which version of SQL Monitor from Redgate supports PostgreSQL? So this is a quick answer. We are so excited about the progress that we're making at Redgate to really support so many things with Postgres as it continues to really become a database that people need to understand and use. So this comes actually from our sample site that you can go, our test site, you can go look at right now. It's just monitor.redgate.com. And we support it as of SQL Monitor version 13. Now, version 13 still does require a SQL Server backend. Again, Monitor has been very focused on SQL Server for a very long time. The team is working right now to make sure that before this year is out, that's the hope, we will have a version of Monitor that will work on a different database, very likely Postgres, but a database that doesn't require SQL Server. But if you are currently a SQL Monitor user, you can begin to monitor your Postgres instances right now, today, if you would like. Please go look at monitor.redgate.com, look at the Postgres instances that we have up there for you to sample, and begin to understand how you could effectively monitor and alert on your Postgres databases. Can Postgres backups be encrypted? It's a great question, and one I understand why we're asking it, but out of the box, there is nothing you can do in Postgres to encrypt your backups. Now, there are a number of ways, depending on your operating systems and the things that you have access to, that your backups could be encrypted at rest. Part of the reason is Postgres core that you get, the open source version, does not currently have any kind of transparent data encryption. It has been something that the community has worked on a number of times, continues to make progress, and really is working to make sure that TDE becomes a core feature soon. But because it doesn't exist by default, it's hard to really encrypt your data at rest as part of the system. Now, many disk systems, whether you're using external storage, even some operating, storage, things like that, will encrypt the page level stuff at rest. So that still works. There are ways to do things like encrypt columns of data. So PG Crypto is a really popular extension for doing that. There are some hosted solutions that do provide options for both encrypting data, TDE, their fork of Postgres that does TDE, and even maybe some backups. I would say this: talk to your vendor, particularly if you are hosting it with someone. Understand what they do, how they secure your data at rest, and take that route. That's the best answer to give right now. If you want to look at what's happening with TDE, there's been a lot of discussion and continues to be progress made. I really hope within the next 2 or 3 releases of Postgres, major releases, we'll see some kind of TDE come to life. So that is what we can say about backing up Postgres and what it looks like to do encrypted data right now in the core version of Postgres. How are security patches handled as part of the release cycle? So I mentioned this actually in the first webinar, and someone referenced this in the question. So we talked about how there's almost a yearly cadence. There have been a couple times where it's been longer than 12 months, but generally it's almost always right on about 12 months. There's a major release of Postgres. Right now, they're targeting Postgres 16 for late fall, hopefully around October. And so the question was, what happens if there is a security incident and we need to have a quick patch? And I'd simply say this. Typically, again, I covered this in the first webinar, there are 5 what we call commit fests each year. One of those commit fests is really targeted at that major release in the fall, and then there's a cadence of 4 other minor releases throughout the year. However, there have been a couple times where there's either been a security patch or actually an issue with a feature that needed to be fixed right away. The most recent one was in Postgres 14. Before Postgres 14.4, if you did an online concurrent update of an index, it could get corrupted. When that was discovered, they quickly fixed it. They put out a patch within a matter of a couple weeks at best. It might have been sooner than that. And all of the major vendors updated very quickly to Postgres 14.4. And so when necessary, they absolutely will release out of cycle. The community is very, very upfront about what is going on within the system. In fact, I'd say this: Postgres is built on openness and security. That has been what it is. It is the preeminent open source database. The way that it handles code, the community handles code, it's there for anyone to see. It's really hard to hide if there's an issue. And so the community works very hard at it. And it's something that I think you'll be really a pleasant experience for you, just knowing that those things are taking place and it's very much in the open. Are there in-memory OLAP or column store-like indexes? This is a great question. So, that was really one of the great features back with, what was it, SQL Server 2012. Sometimes I forget the dates, when we got access to column store indexes. There's a lot of useful cases for doing analytical kinds of queries where column store data and column store indexes is really beneficial. Out of the box, there is no specific column store support within Postgres. Now, there are a number of extensions or forks that actually take Postgres as the core engine and add column store-like data. A couple of examples I can point to pretty quickly. One is Timescale. I mentioned Timescale before. It's a company I used to work for. They do a time series extension, so a database that's built on top of Postgres as an extension. One of the things Timescale does is you can compress time series data, get really good compression, 90% in some cases. And what it's actually doing is changing that data into columnar form, and it makes historical queries really fast, and it saves you a lot of disk space when it's doing it. Citus does something very similar. So the Citus extension is actually what runs the Azure DB for Postgres, or the Cosmos the Cosmos Postgres version. It does something similar to Timescale. I don't know all the details, but it does have a columnar kind of compression as well. Swarm64 was a company and extension recently bought by ServiceNow. It actually will add a true columnar index onto your data to make queries very fast. And then AlloyDB has added some kind of columnar storage engine to their new offering. So AlloyDB is Google's hosted solution, kind of analogous to the Cosmos DB for Azure, and they have added some kind of columnar storage engine. I would guess you'll see more and more of this within maybe the core product and within Postgres, extensions and Postgres versions as they come up. So keep an eye out for it. You will find opportunities to use column-like indexes and storage within Postgres. Is there something similar to DMVs that would help us analyze memory and database performance? A really good question, and I understand why you're asking it. And so the answer is it's generally yes. Now, as Postgres has matured, more and more of this data has become available. So I would say first, start with the stats views. I'll show you the URL in just a second. There are many of these views, both that look specifically at queries, tables, replication, all kinds of things happening within your database. pgstatal tables is maybe a really good first place to start. See the kinds of things that are happening. There's an index view, a stat index view. pgstat statements will show you per statement what's happening cumulatively over time. I referenced that one during the webinar. pgstat.io was introduced in PG15 and is getting more information in PG16. Really nearly every major release over the last certainly 4, 5, or 6 releases has done something pretty major in the way that it's giving us more and more ability to observe what's happening inside of Postgres. So certainly check those out. There's other extensions not part of core that you can install, something like pgstat kcache, and that will get you things related to the actual server and how Postgres is interacting with the resources on the server. And then you could write your own with a number of methods. I did reference that you can actually write an extension in almost any language. The PGRX framework is a REST framework for really doing some pretty awesome things with extensions in Postgres, giving you all the tools necessary to get into the hooks of Postgres to get that information out. So a lot of cool things happening, a lot of opportunity to observe inside of Postgres. I would say start with the docs, look at the cumulative statistics system. This is all the views. There are lots of them that will help you see everything happening inside of your running server. And again, you can install some others that are not part of this core code base to get even more information. A lot that you can do with Postgres and observability. I love this question. What is the first problem to solve when moving from SQL Server to PostgreSQL? That's a really tough question to answer. I've been at this at some level. I've been thinking about this for almost 6 years. And I keep, I have a little bit less SQL Server experience as time goes on, but a lot of application experience in moving from one to the other and things I've had to think through. It's really hard to narrow it down to just one. I will say this. Things like configuration that we talked about, memory configuration and tuning all of those configuration settings, even the first 4 or 5 that we talked about in these first webinars, is a really good place to start. We are used to writing a query, SQL Server managing that whole clump of memory for us in a way that hopefully would be beneficial to what we're doing. Postgres gives you more knobs in how to particularly manage your memory. And so I really pay attention to those, read up on what that looks like, and do your best to tune those things. If you have inline code blocks, learn how to write that. As I showed really briefly, you can't just say declare at variable and write some T-SQL, because that's what it is. It's T-SQL, it's not SQL. And so when you need to do that, you need to learn how to change that code into things like inline code blocks. Functions and store procedures, the way that you reference variables, some of the ways that you do looping, for instance, all of those are a little bit unique within Postgres. Your replication in your HA, lots of good documentation, examples of blog posts on how to do that well. And then honestly, I would say learn how to use some of the features that you maybe aren't using in SQL Server because of licenses. Things like concurrent index rebuilds. It's a simple one. A couple quick examples. Things like data type specific indexes. As I said, Postgres has 6 or more kinds of indexes that you can use out of the box for doing some really cool things within Postgres. You don't have those kinds of indexes in SQL Server, so think about what that might do. And then last but not least, just look at your tooling. That can be honestly one of the more frustrating parts of getting used to Postgres as you come to it as a SQL Server developer. So find some good tooling that you feel comfortable with, learn the ins and outs of it so that you can just be effective in the job that you're doing. Those are my first things. I'm sorry it's not just one, but hopefully that's helpful as you begin to look at moving from Postgres to SQL Server, from SQL Server to Postgres. What is the equivalent of a link server in Postgres? A really good question. There is nothing exactly like we are used to in SQL Server. You cannot ad hoc query an external database in Postgres. It might not be the best practice, but there are absolutely times within a running environment you can literally, in SQL Server, reference a database on the same server instance and query that database as long as the user has access to that database. You can't do that in Postgres. There are no references out to other databases, as I said, on the same instance. Instead, you can do things like foreign data wrappers. And so this is analogous to external tables and the things that really became introduced in SQL Server 2012 and 2016 and so forth. So there's lots of them. A few of them are included in Postgres core. So Postgres FDW is a foreign data wrapper. MongoDB, ClickHouse, Oracle, SQL Server, Redis, and so forth. There are lots and lots of these extensions you can install, which will then allow you to do foreign queries, but you do have to set up an external table with which to query. And then Postgres will send that query down to the server, get the results back, and parse them for you. It is not quite the same as a link server. So you will have to, when you use a foreign data wrapper, you have to create the connection, map users, add it as a foreign table. And the one thing I'd say is push down is pretty tricky the more complex a query gets. So if you do predicates, you have to be careful about how you write those queries with the predicates to ensure that they will be passed forward to the foreign server. Otherwise, you're going to get all the data back, and then the local Postgres instance will have to filter that data for you, and it can be slow. Last but not least, you can actually store statistics for foreign tables on the local server to make the query plan better. However, if it's a quickly updated or often updated table on the foreign server, that's not going to do you a lot of good. And that's why you really need to make sure that you have well-written queries that will push those predicates down to the server so that the foreign server will do the parsing and the filtering for you first before sending the results back. That's the best case scenario. And so really think about whether or not you need to analyze and store statistics locally for those foreign tables. That is how you can query foreign data and foreign Postgres tables within Postgres. Any suggestions when migrating from SQL Server to Postgres? Really good question. I'll be honest, most of my experience has been hard-won through a lot of work. As time has gone on, however, there are some solutions that might be a really good step forward. So there's often no easy shortcut. I talked about Babelfish really quickly. That is an Amazon setting or an Amazon offering within their RDS and Aurora service that will allow you they will help you migrate your database and then run your T-SQL against it at some level until you slowly over time migrate your application to use PostgreSQL. But there's really no straightforward, easy one-off solution. I do know a number of people that have used the Amazon migration service. Please have a look at it. Most of those people have had a generally good experience, and I think it's an opportunity, particularly if you're hosted within Amazon. One other tool I've come across a few times is pgloader. So pgloader is written by a long-standing member of the Postgres community, Dimitri Fontaine. He and others have contributed modules to actually convert from multiple databases into Postgres, one of which is SQL Server. So it will use the information schema views to recreate the schema inside of Postgres. There's a number of built-in ways that it will try and convert data types and indexes, schema, those kinds of things into Postgres. And then as new data comes in, it will actually try and continually upgrading and migrating that data from SQL Server into Postgres. It's a really powerful tool, something I would say you should give it a look. And then you can actually create your own rules for PG Loader when there might be a data type or something that isn't working and what's currently available doesn't suit your need. So there's a lot of opportunity here. Definitely give it a try. Look it up on Google or wherever you search for PG Loader, and there's a lot of good documentation and examples to try there. Hopefully that's helpful. This is an area where there's more and more work being done, and I think you'll see more opportunities in the year or couple years ahead. If you would like to get a hold of me, please come get in touch with me through Twitter. I reference all of this stuff on the webinar. LinkedIn, please check out my blog. I'm doing more and more blogs now, specifically about things to look at as a SQL Server developer or DBA as you're moving to Postgres. I believe the title of the series is Postgres for SQL Server DBA, but a lot of it could easily be for just developers as well. I do stream a little bit at YouTube, and more of that is Postgres content, and so continue to check that out as well. But seriously, don't hesitate to reach out. I would love to connect with you, understand your story, and see how I can help you in your journey towards Postgres. It's been a pleasure. I hope this has been helpful, and we look forward to seeing you at the next webinar. Take care.